In Griffiths, we are having the curvilinear coordinate system. This is section 1.4. This is curve, and it is curvilinear coordinate system. So curvilinear coordinates. And inside the curvilinear coordinate system, we will have the spherical polar coordinate system first. Is 1.4.1, the spherical polar coordinates. Now consider our x is now like the three-dimensional. Now our coordinate system is having the x, y and z components. So this is our one axis, this is another, and this is our x-axis, this is y-axis, and this is z-axis. Now inside this system, let's say we are having a vector, and a vector is, let's say we are having vector r here. So this is vector r, and now vector r, it will have components in this system. So it will have its projection on the x and y axes, and it will be something like this. So first we will consider its projection on the z-axis. I will make it a little bit tilted so that it looks like a three-dimensional, and this is the component of it which is touching the z-axis, and in the same parallel line I will have for the xy plane here. This will be the projection of this on the xy plane. And now let's say this vector r makes an angle theta with the z-axis. So it makes angle theta here, and its projection on the xy plane is making an angle phi here. So one is angle theta. The angle theta we call is the zenith angle, and the angle phi we call is the azimuthal angle. So theta we call is the zenith angle, and phi is the azimuthal angle. Now here I will have x and y component of this. So this is the x, this is the y component, and this is the x component of it. This is x and this is y component on this plane, and we are having this is the z component, means from here to here this will be the z component. So I can write that our vector r in the three-dimensional I can write is r equals the x component here, the x component in x unit vector, the y component in y unit vector, and the z component in z unit vector. Similarly, according to this one, the magnitude of r will be equal to the same thing, but only one component will be added. So earlier in two-dimensional it was x square plus y square, and now the z square will be added with this one, and this is x square plus y square plus z squared. So we have the magnitude of r here. And now if I would like to find the value of theta, then the value of theta means r is here, so there will be the value of theta as well. But before going to the value of theta, let me find these components here. This is the angle starts from here, so it means this is the base, and it reaches here means this is the high part. So this is the perpendicular one. So I will have this component equal to r sine of the angle, and this component equal to r cos of the angle. So the z component comes out to be r cos theta. While when this one is r sine theta and this side is completely equal, means exactly equal and parallel to this one. So it means the projection is having its length equal to r sine of theta, and let me call this is rho. So this vector is equal to rho here. And as the angle starts, the phi angle starts from here, it means x is the base. And this reaches here, so rho is the high part. And this component is the perpendicular one. So from here I can write that x is equal to, as I did here, x was equal to r cos theta. Let me write here this one, that x equals from here, it is, when I do the conversion, then x is equal to r cos theta and y equals r sine of theta. So I have the conversion between these two. Now here the r is equal to rho. So rho is having its x component equal to rho cos of phi. And if I put the value of rho, then this is equal to r sine theta and cos phi. So x is equal to this, while y here is equal to rho times sine of phi, because this is the perpendicular component. So rho sine phi is the perpendicular component, and this is equal to rho value is r sine theta, and then it is sine of phi. So here I can write these as rho cos phi, and y will be equal to rho sine phi here. So I have found the three components, means x, y, z. They were required one. So I got that x is equal to r sine theta cos phi, y is equal to r sine theta sine phi, and z is equal to r cos theta. So I can write this thing is equal to, r can be written in terms of the polar coordinates. For x I can write r sine theta and cos phi, and this is an x unit vector, plus r sine theta sine phi, and y, this is the y component, and r cos theta in z unit vector. So I have written r here, that r is equal to this. Now I can find the magnitude of r as well from here, and the magnitude of r will be equal from here, that the x component square, the y component square, and the z component square. So I can prove this one, that this is right. This means that r equals vector r magnitude, the x component square, r square sine square theta cos square phi, and plus the y component square. So this will be r square sine square theta and sine square phi, and r square cos square theta. And this is having whole power is 1 over 2. Now I can further write this one, that vector r is equal to r square and sine square theta if I take as common. So r square sine square theta here and here. So it will be cos square phi plus sine square phi, and cos square phi plus sine square phi will be equal to 1. So it means only r square sine square theta remains. So r square sine square theta plus r square cos square theta, take r square is common. So sine square theta plus cos square theta will be equal to 1, and only r square will remain here, and r square to the power half will be equal to r. It means we are right in our calculations. Similarly, we have converted from here the x components into the polar components. Here we are having x, y and z here, x, y and z here, and we converted them into r, theta and phi here. So this is evident from here that x equal in terms of r, theta and phi, y in terms of r, theta and phi, z in terms of r and theta is a perpendicular axis to it, so it is having nothing to do with the plane of x and y. So we have converted it into this. Now what about means we want to find out the theta value and the phi value here. Okay, this one is this phi. This is this phi. So we means r is equal to r, but what theta equals to in terms of the spherical polar coordinates, and what phi equals in terms of spherical polar coordinates. So let's come here, and here this thing is equal, as we know that z is equal to r cos theta. Now I can write from here that theta is equal to cos inverse and z over r. Cos inverse means z over r, and then cos inverse, and theta is this, and I know the value of this one, of the value of r here, cos inverse, and z over r magnitude. So this is x square plus y square plus z square and square root. So I wrote the value of theta here in terms of x, y and z here. And similarly, what about phi? Phi is equal, means for phi we come here to this one, and x is equal, if I divide this equation by this equation, then it will be y over x equals rho sine phi over cos phi, rho cos phi. So rho is cancelled with rho, and we got tangent phi here, and this implies that phi is equal to tangent inverse y over x here. So this give us the value of pi in terms of x and y. It means we have successfully converted the Cartesian coordinate system into the polar coordinate system, and then the polar into the Cartesian. So we had this conversion that x, y and z we converted into r, theta and phi. We call this the angular portion and this the length portion, and then we again reconvert them into r, theta and phi into x, y and z. So here is the summary. X is equal, x in terms of r, theta, phi, r sine theta cos phi, while y is equal to r sine theta sine phi, and z equals r cos theta. This is x in terms of r theta phi, y in terms of r theta phi, z in terms of r theta, and similarly r equals in terms of xyz. Now it is x square plus y square plus z square and square root. Theta equals cos inverse z over x square plus y square plus z square square root equal to this, and phi equals tangent inverse y over x. So we converted this successfully between the two coordinate systems, and now we will consider about the unit vectors, how those unit vectors are changing. So I will erase this side because we are done with this one, and here is we will do some calculations, so I will keep this side.